In this video, we're going to talk about optimization. Let's take a look at this example. It says find two numbers whose sum is 20 and whose product is as large as possible. So our goal is to find the product that is large as possible. So what's going to happen is that you're going to have two equations here. It says sum of two numbers is 20. So x plus y equals 20. But our goal is to find the product that is large as possible. So product of two numbers is going to be x times y. Now, which one do you think we need to find the derivative of? Well, our goal is to find the largest product. So we need to find the derivative of p equals x times y. I call this primary. Primary equation is the one that you need to find the derivative to find the answer. And I call this secondary. Secondary equation is the one that will help you to solve primary equation. And this is what I mean. You have two variables here, x and y. If instead of x and y, if we have a single variable, it's easier to find the derivative of p. In order to do that, let's solve for y. So y is equal to 20 minus x. Now instead of this y, we're going to use substitution. So p is equal to x times the quantity 20 minus x. Now we have a single variable x. So this is much easier to find the derivative now. So p is equal to 20x minus x squared. In order to find the largest product, we have to find the derivative and find the maximum. So p prime is equal to 20 minus 2x. You have to set that equal to 0 to find the critical points. So x equals 10. Now let's check. Let's draw a prime chart. The critical number is going to be 10. And we have to test. Choose a number that's less than 10. And plug it into p prime, you will get positive. Plug in a number that's greater than 10 to p prime, and you will get negative. So indeed, x equals 10 is maximum because p prime changes sign from positive to negative. We can say that the product is largest when x equals 10. When x equals 10, the y is also 10. So product is largest when both numbers are 10. Now let's take a look at the next example. It says a rectangle is to be inscribed under one arc of the sine curve. So this represents one arc of the sine curve, which means that this is going to be 0, and that's pi over 2, and that's pi. So our domain is from 0 to pi. And this is a graph of sine x. That is a graph of sine x. What is the largest area the rectangle can have? And what dimensions give that area? So we need to find the largest area of this rectangle that could be contained inside or under this arc. So basically what we need to do is we need to find the length of L and W of this rectangle that will give you the largest area. So area is going to be L times W. So this is our primary. Because we need to find the derivative of area to find the largest area. But again, we have two variables. We want to make it into a single variable. So we need to find secondary equation. Now take a look at L here. The distance from 0 to this will be x. If this is x, then this is also x. So we could say that the length of the rectangle will be pi minus 2x. Think about it. You got x, you have another x, so distance of this L will be pi minus 2x. Now what about the width? The width is from here to the curve, sine x, which is going to be just y. From distance from here to the curve is y, and in this case, y is sine x. So w, the width will be sine x. It doesn't matter where x is. The y value is going to be sine x. So now, using substitution, so these two are the secondary equations. So area is going to be quantity pi minus 2x times sine of x. Now, we need to find the dimensions that will give you the largest area. So in other words, we have to find the derivative of this. Now, this looks pretty complicated, so what we're going to do is we're going to use our graphing calculator. Graphing calculator helps you to find the graph of the derivative of original. So let's say you want to find the graph of the derivative of this. What you need to do is you press math and go to n derivative, so number 8. Our variable is x, so we're going to find the derivative of x. What do you find the derivative of? We find the derivative of y1. So instead of putting this whole thing again, we want to choose y1. So press alpha, trace, and click number 1 for y1. And then you're graphing the derivative of all the x values, so we're going to put x over here. Now, this is a setup to find the derivative of y1. Now, notice, I deselected this equation so that I only get to see the graph of y2. So let's graph it. Now, notice the window, I went from 0 to pi, because that was our domain. 0 to pi, and you need to graph it. So you get this. So this is a graph of a prime, the derivative of a. Now notice, a prime is positive over here, and it's negative over here because a prime is below the x-axis. So in order to find the largest area, a prime has to change from positive to negative, which is over here. So we need to find the value of this. By the way, this value right here will give you the minimum area, the smallest area, because a prime changes from negative to positive. So in order to find this value, we have to use 0. So second, trace for calc, and choose number 2 for 0. Left bound, you need to go left side of the 0 that you want to find. Click enter. Now right bound, go to the right side of the 0, press enter. Forget, press another enter. And it gives you the 0, which is 0.7104628. Is largest when x equals 0.7104628. Now, the length is pi minus 2x. So you got to plug in x over here. So length is approximately 1.721. And to find the width, you got to find sine of this value, which is approximately 0.652. So this is a dimension that will give you the largest area under the sine of x.